I'm always leery about teaching special products. It is part of the curriculum. And as I go back, previous lessons dictated that you learn how to do double distributions, you learn how to do triple distributions, because they always work. They'll never fail you. These special techniques, the special product, if you don't fully understand it, it's going to cause you to miss problems. So I would strongly encourage you to definitely learn the double distribution and use that forever. And then as you become more comfortable, these ideas just make you quicker. So they make you faster when it comes to multiplying the binomials. Example 1. Now we're going to call these difference of squares. Difference of squares. And you'll see why we call them difference of squares after I do a couple examples. If I want to multiply 2x minus 3 and 2x plus 3, I notice that I have the same terms but different signs in my parentheses. So as I go through with this FOIL process, I do first with first. 2x times 2x is 4x squared. And then I move to the outer and inner products. Outer produces the 6x here. Inner produces negative 6x. So the middle term drops out. And then when I finish FOIL, negative 3 times 3 would be minus 9. And the reason why they call that a difference of squares, 4x squared was something times itself. 2x times 2x produced that squared component. 3 times 3 is a square number. That gives you 9. And obviously in between there we have a minus, so we get it as a difference of squares, difference of two square values. And of course we'll do several of these examples too. You can see all the different ways that these will be presented. Maybe we'll say something like this. We'll say 5x minus 7, 5x plus 7. And so again, I'm going to use my FOIL. I want to do first with first. 5x times 5x would be 25x squared. Outer would be 35x. Inner would be negative 35x. The middle term gets negated. It drops out because they're equal but opposite in value. And then last with last would be negative 7 times positive 7, which is negative 49. Again, the name is called difference of two squares, difference of squares, because this is a square value, this is a square value, and there's a minus in between them. We'll do example number 3. We'll try to mess you up a little bit. We'll say 5xy minus 1, 5xy plus 1. It doesn't matter if the plus comes first or second, just as long as you have one of each sign. When I multiply first with first, that produces 25. X is x squared. Y is y squared. The outer would be a 5xy. The inner would be a minus 5xy. The middle term drops out. As that middle term drops out, we move to the last with last. Negative 1 times positive 1 would be a minus 1 right there. And so once again, this is a difference of two square values. We'll do one more example, and by then you should be pros with this. Call it example 4. Goes back to the concept I said at the beginning of the year. You need to know your squares. Why? Because if I throw a problem like 15a minus 13 times 15a plus 13, this shouldn't be something where you're taking 10 minutes to throw it in a calculator. You should know your squares. First with first would be 225a squared. Now, the only thing that might slow you down are these products, but by knowing the nature of the beast, would you agree that 13 times 15 and negative 13 times 15 forces that middle term to drop out? I don't need to know what it is. I can go directly to the last with last. Negative 13 times 13 would be negative 169. And so I have a square component minus a square component. That's a difference of squares. And that's one of our special products. One of our special products. Well, I'll go through another section here which will deal with perfect squares. That's our other special product.